Okay, so before we get into any detailed analysis of time series or any forecasting itself, we need to understand how Python works with dates and how it works with time series. So in this notebook, we're going to look at how Numpy and Pandas store and process dates and times. We're going to learn how to manipulate those, and we're going to learn how to do useful things like read those dates and figures in from a comma separated value file, a CSV file. So this isn't too complex. It's just a few nuts and bolts of Numpy and Pandas that helps us do our time series analysis. So we've got some standard imports that are worth including at the top of any notebook or Python file where you're going to do some forecasting, which is Numpy and Pandas. And we're going to start off by looking at date times in Numpy. So Numpy has a data type that it uses to manage date times, and that's datetime 64. So we'll take a look at that now. What we're going to see is that datetime 64 can work at different levels of precision. So it can work all the way down to the nanosecond, but we'll mainly be using it at things like the daily level or the monthly level or the hourly level or something like that. So not quite so precise, but there's the ability to use it for very high precision scientific analysis is there. So we'll start off by looking at how you create a static array of date times. So that's what this cell is doing here. We're creating a NumPy array with np.array, and we're passing in a list of strings that represent dates. So we can see here that the first date is 2019, the 7th month and the 11th day. The second date is 2019, the 7th month and the 12th day. So the eagle-eyed amongst you will see that that is just a sequence of days. And we're giving this NumPy array a data type. We're saying data type equals date times 64. So when we run that, NumPy returns an array for us, which is exactly what we want. We have our date time values in there, and we can see that NumPy has done some automatic processing of the data. And this D in square brackets here means that it's identified that that's daily level data for us, which is very useful. So you can go much further than that if you want. You can have data with a time attached to it. So to do that, you add in a letter T, and then you add the hour after it. So here we've got 1 a.m. Here we've got 2 a.m., 3 a.m., and then we've got randomly 5 o'clock in the afternoon. So that's 24-hour time. So again, we're just doing the same thing. We're creating a static NumPy array. And what NumPy has done is identified that that's hourly data that we're working with there. If we wanted to go further and have minutes in there, you just need to put a colon and then the number of minutes out of 60. Let's run that. And you can see that NumPy has picked up that this is data in minutes. All I did there was add in a colon. If you wanted to go for seconds, you'd just add in a second colon and then put in the number of seconds. And you can see NumPy is very happy with that, and it's picked up that that's date time all the way down to the precision of seconds. If you wanted to, you could go further than that. As I said, you could go down to the nanosecond if you want, but here we're just going to go down to milliseconds. And to do that, you add a dot after the seconds and include how many milliseconds are included. And Python's very happy at picking that up. So if you are using this for very high precision measurement, Python and NumPy are very happy to work with that type of data for you. So that's quite different from some other programming languages. So NumPy is very geared up for pure scientific computing, so it's very useful. So not always very helpful to just create things by typing static text in. So a more useful operation is to create a date range. And Why would we do that? Well, we would probably do that when we're testing our code or when we're trying to figure out how a forecasting method works. For example, we might want some toy data, some synthetic data that we generate ourselves, that we control, that might have a very specific distribution or might be a very simple type of value. So we can create a date range very simply by using np.a range, which is a function built into Numpy. It has the start date, the end date, and the step that you want to take. So here's an example of that. np.a range, I'm passing in the start date, which is 2009-07-01, and I want to go all the way up to 2007-31. I'm going to go in steps of 1, and that's going to be at the daily level. Okay, so this final thing is telling NumPy what data type it is. So it's going to produce days, and it's going to go in steps of days between those two dates. So let's run that. Okay, so here's all of the days between those two dates. Now what I could have done is I could have said, okay, let's go up in steps of 2 and run that again. And so you can see here that it's jumping between the 1st of the month and the 3rd of the month. So it's added 2 days to it. And you could go even further. You could go, I'm going to go up in 3s. Okay. So you don't, when you go up in an odd number like that, you don't quite get to the day that you want. But it's still a quick way to produce a range of dates rather than typing those in yourself. Now we're going to try and do the same thing. We're going to return that array into a variable called foo. So we're going from 2019-07-01 all the way through to the end of the month in steps of 7 in minutes. Oh, goodness me. And then we're not going to print all that out because it's enormous. We're just going to have a look at the shape. And we can see that's produced 6,172 data points for us, which are dates going up in steps of 7. So that's quite useful. You can see very quickly that I'm able to quickly produce dates and times over a large range of values. So that's quite handy for starting to generate some synthetic state data. You don't have to use this step variable here. If you omit that, if you omit it, then it's just going to goes up in 1 steps. Its default value is 1. So that's all what we're showing you here. Okay, so that generated data between the 1st and the 10th of August, going up in steps of 1. So that's NumPy, and it's important to learn about NumPy first because NumPy is the fundamental building block of the SciPy stack. It's what all the scientific parts of Python use, or at least if they're not using that, they should be using it. So sitting on top of NumPy is Pandas, which I know you've come across before. But the sort of Pandas we're going to look at now is specific for time series and forecasting. So one of the key differences is we're going to have a special type of index in our array, and that's going to be a date time index. So that makes this is the easiest way to work with time series data in Python. And you should be aware that many of the built-in Python forecasting methods that we will look at require your data to have a date time index. So we need to learn how to use those. And in a way, it's quite similar to working with NumPy because that's what it's sitting on top of. The other thing we will talk about with Pandas, which is better than NumPy, is it can deal with this issue of United States format of dates versus the UK. So the US has this really irritating version of dates where they flip the month and the day, and that causes havoc in all sorts of programming languages. But Pandas and Python have got some built-in functionality to help you deal with that. But you do still need to be careful. So to create if you wanted to create some data yourself, that's really straightforward. Perhaps slightly easier in Pandas than it is in NumPy. So Pandas has this date range function. So here I'm going to pass in a date. I'm going to say that I want to calculate 7 periods at the day level. So it's going to calculate 7 days for me. And I've got a little note above that to remind myself that Pandas by default, because it was originally written by an American, it will have dates in this format where it considers this first value to be the month, which of course we all know is incorrect. So let's quickly run that. So what you can see it's done is it's created 7 values for us, and as you can see, rather than taking this is the third day, it's taking it as the third month, and it's counted up in those values. So that's a little bit annoying. Okay, so we're going to look at a way to deal with that at some point. So what you probably would do here, for example, is this. If you were just creating it yourself, you would just kind of live with the fact that Pandas has this American flavor to it by default. So you can create data at different frequencies. So that's what this freq parameter is. So here we're going to create 7 periods, 7 values at the hourly level. Let's run those. So you can see what it's done is it started off at midnight and it's added an hour to each increment. So it stayed on the same date and it's just added an hour to it. So it's really easy to create data at different frequencies. One of the things you might be working with is monthly data. So for that you would use what's called monthly start. And if you run that, you can see what it's done is it's just jumped to the next month at the start of the month. And you can see underneath what's going on is it does have this NumPy type. So here it's a Datetimes 64, actually down to the nanosecond if you want it. So that's what's going on underneath Pandas. NumPy is there lurking in the background doing the heavy lifting for you. But Pandas is kind of a nice friendly way to sit above NumPy. And the other thing that the index gives us, so you can see this is a date time index that's returned, is it tells us what the frequency of that is. So you've got a data type and a frequency. What about if your data's in a Python list? Can you convert that to a date time index to work with Pandas? The answer is yes, you can. So here we've got an example, and let's run this. And you can see what it's done is we've just created a list here called dates, and we've passed that into a pd.datetime_index object and saved that in the variable index, and then we've printed that out. And what we can see is the first date is 2009, so it's the 1st of January 2019, and then it's the 1st of February, and then it's the 1st of March. So that may not have been what you wanted. So if you, for example, working with UK data and your data was in this type of format, which it might be if you've read it in from Excel or something like that, then you might have this mistake in your code that you haven't realized about. So it's always important to have a quick think about, are there any issues with US to UK data translation, or UK from US to UK to US data translation? If there is, you can just pass in this parameter that says day first, and that's telling Pandas that this data is in, dare I say it, the correct format, and this is the day, this is the day, and this is the day. So when we run that, we get the first 3 days of January. So like a list, it's exactly the same process if you're working with a NumPy array. So here we've got a NumPy array of Datetimes 64 objects, and it's 3 days. If we run that, you can see what it's done is it's done exactly the same as it would do for list. It's created a date time index. These are the values within it. It's got a data type, but confusingly, its frequency is none. So it hasn't been able to work out what the frequency of that data is. So there's no kind of automatic thing going on there. So there's two ways to sort that out. The first is so this is the same code as up here. When you create your date time index, you pass in a frequency value of D and run it. And now we can see that Pandas knows, this date time index object knows that it's of daily frequency. Now you may say, so what? Well, there's a bit of a gotcha here. If you forget to set that, then some of the forecasting methods that we will look at will get very upset with you and throw an error. So it's important that you remember to set it. And that's one way of doing it, by passing it in here. Another way of doing it is to create your date time index, and then afterwards index.freq equals whatever your frequency is, in this case D. So if we run that, out pops our date time index with the frequency set. So a little bit fiddly, but once you get into the swing of things, you will remember to do that. There will be no problem. And you'll see that we do it again and again in the examples as we go through the course, just to reinforce that. So once you've got your index, you can get useful information out of it. So for example, if you wanted to know the minimum date within that date time index, you can just call off the index objects. You can just call the minimum method, the min method, and that returns a timestamp with the minimum value within it. Of course, you could then get the maximum, no problem. You can go further than that. You can choose a specific date, and here we're choosing the minimum, and we can get to the elements within it. We can get the year, the month, and usefully the days in the month. We'll see how useful that is later in the course. So just print those out, so you can see that for that minimum date, I'm able to get at the fact that it's 2019, it's the 7th day, and it's there's 31 days in that month. So that's quite useful. So what you'll be doing in practice mainly is working with reasonably large data sets that contain time series data that you want to forecast what's going to happen next. So that data typically, well, it might be in an Excel file. I would advise you to save that data as a CSV file, just have it in a nice clean file without any type of formula or anything in there getting in the way. Just have a file that's a few columns with your time series data in there. And what we're going to work out now is how do we read that data from that file into Pandas. And it's very, very straightforward indeed. There's just a single command to do it. What we're going to do first is we're going to create some synthetic data that I'm going to save to a file, and then I'll show you how to read that in. So that's really easy to do. I'm going to create some data that has what's called a Poisson distribution. So the Poisson distribution, don't worry about that too much. It might sound scary, but it isn't. You use it when you're trying to model something like the number of arrivals to a system. So for example, if you were modeling the number of arrivals to a bank over a day, you would sample from the Poisson distribution, and it gives you a whole value back, an integer value back. So that's what we're doing here. So I've created an index. It's got 365 times 2 periods of days, starting from the 1st of January 2018. And then I've sampled that many periods from the Poisson distribution, bunged it in a data frame, and then I'm just saving that as a CSV file called exampledata1.csv. So here's an example of what the data that it's generated. I've got this date time index here and sales. So that's typically what your time series data will look like in raw format. And we can also just drop out a second and look at the CSV file. So I'm doing this in Jupyter Lab, I'm not doing it in Excel. And all you can see is if you'd have opened this in Excel, it would look the same. You've got one column for the date, which is going up in days from 2018, and you've got one column for the sales. And you can see as you scroll down that, the date gradually increases and the sales stay within this distribution that you specified. Okay, so we've created our CSV file, and now what we would like to do is read that in. So in practice, that first step wouldn't be there. I've just put that in so that when you run your code, you can create a file that you can read in. So you can see there's substantially less code to read in data than there was to generate that data and output it. So we're going to use off Pandas. We're going to use this method or this function called read_CSV, and it pretty much does what it says on the tin. You specify the CSV file you want to read in. You need to tell Pandas what the index column is, so which column contains the dates, and we would do that by basically using this index col parameter. And so the column is called date, so we just say index col equals date. We need to remember to tell Pandas to parse the dates. Okay, so that makes sure that it doesn't read it in as a string. It's really just saying these are dates. These are dates. Please treat them as such. And then once that's read in, we will need to set the frequency, which we know is daily level data. So if we run that, have a look at the index, we can see it's read that index in, and it knows it's the date. It's of data type datetime 64 to the nanosecond, and Pandas knows it's daily level data. Let's have a quick look at that head of that. In fact, we can look at a bit more of that if we want. So a bit more data. So we can see this matches what was in the CSV file we just saw. We've got our date column, which is our date time index, and then we've got our sales. Okay, and that's all the thing we really need to remember is that underneath Pandas is Numpy. Numpy's doing the heavy lifting for us. Pandas provides a nice framework for working with time series data, and it should always be our first port of call. Get our data into Pandas before we think about anything else. That's the first thing you want to do. And going forward now, we'll have a look at how we can start visualizing what our time series data looks like. Again, we will use Pandas to do that.